Hi guys, so today we're going to talk about dilutions. You've probably done a dilution where you've had a liquid that you haven't wanted it as concentrated as it was. So an example for me is when my kids were little, I didn't want them to have too much sugar in their beverages, but they loved apple juice and did not really enjoy drinking water. So I would dilute the apple juice with water so that really they were drinking more water, but they thought they were drinking apple juice. And it was funny because it wasn't until they were older kids, maybe like 7 or 8, they were at other people's houses and drank fully concentrated apple juice and actually did not like the taste because it was too strong. But we all have things that we prefer more dilute than they come. Another example of this would be laundry detergent. Laundry detergent now comes more concentrated, and you use a smaller amount of laundry detergent for the same amount of water in your washer, so that the laundry detergent itself is more concentrated so that they have less packaging and it costs less money to ship it because it's a smaller container. So for the same size box, you can, ship 20 containers of laundry detergent compared to 10. So it's more economical for cleaning supplies to be more concentrated. And then when the consumer buys the cleaning supplies, they dilute them, usually with water. So the formula for dilution is actually really easy. So here we can see, here's the formula. M1 times V1 equals M2 times V2. And what does that mean? So remember that M molarity, and remember that molarity is the moles of solute over liters of solution. And V, as it is in lots of formulas, means volume. Now that M1, V1, that 1 means initial, or our first concentration in volume, and that 2 means final. Here we have 2 liters of a 0.88 molar solution. So this right here is our initial solution. So that means that our M1 equals 0.88 molar, and our V1 is 2 liters. And we want to dilute it to 3.8 liters. So what we're saying is we have this solution, right? Maybe it's laundry detergent. So here's our laundry detergent, and we need to get 3.8 liters out of it. That's how much we need. So we're going to add some water to that concentrated detergent, and we want to know how strong will it be after we add enough water to it to have a total of 3.8 liters of solution. So we know that our final volume is going to be 3.8 liters, but we want to know how strong will that solution be? How strong will that laundry detergent be? So we fill all these guys in to this formula right here, and we can see it all substituted here in the second round. And to get our answer, we're going to divide both sides by 3.8 so that this cancels out. And therefore, our final concentration will be 0.46 molar. And so if we're talking about laundry detergent, we might want to look up and see, is that strong enough? Is our laundry detergent still concentrated enough to be effective in cleaning our clothing? Or have we diluted it too much and our clothing won't actually be getting clean? So dilutions are important because we want to make sure that we still have chemicals that can work. We haven't diluted them too much. Let's try a second problem. Explain how you would prepare 35 milliliters of a 1.5 molar nitric acid solution from a 6 molar stock solution. Okay, so when it talks about stock, that means that that is our initial amount. So this would be like I go to the chemical storeroom and I'm going to take this off the shelf. So our M1 equals 6.0 molar. That would be, I would buy it from the chemical supply company. And I want to make a solution for you guys to use in the lab that has a molarity of 1.5. So my final concentration is 1.5 because 6 molar is pretty strong. That would not be safe for you guys to use. So I would want to dilute it to 1.5 molar. And when I calculate out how much everybody needs, I see that I need 35 milliliters is the amount that I need, because I don't want to make, 2 liters worth when I only need a small amount. So we want to convert this guy to liters by dividing by 1,000 milliliters in 1 liter. So that means our V2 is going to be 0.035 liters. And what we're trying to figure out is our V1. We're trying to figure out how much of this 6 molar solution am I going to bring up to 0.035 liters to have a 1.5 molar solution. So how much do I need in order to get the amount and concentration that I want? And so we use this formula right here. We fill in all our numbers and we see we're going to divide both sides by 6 so that our volume gets by itself. And so our V1 is 0.00875 liters. That's pretty small, so we would convert that to milliliters. And we would use a graduated cylinder to measure out 8.8 milliliters of that stock solution of nitric acid. And then we would bring it up to, how much did we need? 0.035 liters or 35 milliliters, and bring it to that total volume there. So we can see we diluted this very strong concentration of nitric acid to be a more dilute solution. So dilutions are really important to make sure that we aren't using too strong a material or too weak of a material, and we aren't wasting any of the material. All right, thank you guys.